All right, we're going to continue today talking about the next lesson, which is lesson 9.5. We're continuing to talk about multiplying polynomials. So we've talked about how to multiply polynomials in general in lesson 9.3. Lesson 9.4, we talked about how to multiply binomials by using the FOIL method. Remember, first numbers, and then the outside numbers, and then the inside numbers, and then the last numbers. And today we're going to be talking about a shortcut, how to solve certain problems by simply using a template, we could say. So, for example, if I have two numbers being added and then squared, so I have a polynomial, but it's an adding polynomial and it's being squared. If I use the FOIL method and just work it out with a and b, I end up getting a squared plus 2ab plus b squared. So what this is saying is anytime I have anything in this format, I can take my first number, square it, add my first number times my second number times 2, and then add my second number squared. And that will be my answer. So over here I have an example, 3x plus 4. So 3x, that's my first term. So I'm going to start off by squaring 3x. So we're going to have to square both the 3 and the x. So I'm going to square the 3 and the x, both of them. So 3 squared is 9. X squared is x squared. Next, I'm going to add my first times my second. So my first is 3x, my second is 4, times 2. So I'm going to do 3x times 4 times 2. So since all of these are numbers, I can use the commutative property, rearrange them, multiply them all together. 3 times 4 is 12, times 2 is 24, so I have 24x. Finally, my last step, I did my first term squared, plus my first term times my second term times 2, plus my last term squared. So 4 squared, that's simple, that is just 16. So I have 9x squared plus 24x plus 16. So this is a method I can use anytime I have a binomial, two terms, inside the parentheses being squared. Anytime I have a binomial being added and squared, all I have to do is take the first term and square it. Then add the first and the second term, multiply together times 2, and then add the last term squared. So we call that the square of the sum, because I'm adding and then squaring. What about if I'm subtracting? Well, if I'm subtracting, you can see here, if I have a minus b squared and I work that out, I end up with a squared minus 2ab plus b squared. You can see it's the exact same as when I'm adding. The only difference is instead of adding that 2ab, I subtract it. So notice here I have a subtraction, 2x minus 5y squared. So it's a binomial, it's a subtraction, the difference being squared. So again, I'm going to take my first term, my a here is 2x, so I'm going to do 2x squared. Remember, when you square that, square both the 2 and the x. Make sure you square both of them, so that gives me 4x squared. Then remember, I'm going to multiply 2 by my first term, which is 2x, and my second term, which is 5y. Now in this case, if I'm using this template, I'm not going to use that negative sign. So it's just going to be 2 times 2x times 5y. So I'm going to do minus from there, and then I'm going to do 2 times 2x, because that's my a, that's my first term, times 5y, because that's my b, that's my second term. Again, anytime I have numbers, I can multiply those numbers together. So I end up with 2 times 2 is 4, times 5 is 20, x, y. Finally, my last step is I'm going to add b squared. My second term is 5y, so 5y squared is 25y squared. Remember, I'm squaring both the 5 and the y. So if you have a binomial, two terms that are being subtracted and squared, I can always use this formula. Whatever the first term is squared minus whatever the first times the second times 2 is, multiply all the numbers, plus whatever the last term is squared. And then that will give me my answer. There are no like terms, so that's my answer. Finally, we have something called conjugates. So we've looked at the square of a sum, which is when I'm adding, if I were to do a plus b squared, so anything plus anything else squared. We've looked at the difference, the square of a difference, that's when I have anything minus anything squared. Now we're going to have conjugates. Conjugates are when I have something plus something times something minus something. So these are called conjugates because in the conjugate, both of the first numbers or letters must be the same, and both of the second or last numbers must be the same. But then they must have different signs. I have a plus and a minus. So when I have the same first number, the same last number, the first one's being added, the second one's being subtracted, I can simplify that into simply the first one squared minus the second one squared. So if you look at this last example I have here, 3x plus 7y, 3x minus 7y, notice the first one in both is 3x, the last one in both is 7y. The first one is being added, the second one is being subtracted. So, since this is in the same form, we call these conjugates. Since they're the same things being added or subtracted, the only difference is one is being added and one is being subtracted. What I can do is I can take the first ones and I can square them. So 3x squared is going to be, again, 9x squared. Remember, I square both the 3 and the x. And then 7y, and I'm going to subtract. Use the subtraction symbol. And then 7y squared, 7 times 7 is 49. Y times y is y squared. So that's my answer. It's that simple. If I have conjugates, all I need to do is a squared minus b squared. My first number squared minus my second number squared. And that will be my answer. So to review all this really quickly, I have here a summary. If it's a square of a sum, that means you have anything plus something else squared. I do my first number squared plus 2 times my first times my second plus my second number squared. Square of a difference, that's if I'm subtracting. If I'm subtracting a minus b squared, I'm going to do again, this almost exactly the same as a sum. The only difference is I have the subtraction symbol here. Finally, if I have the product of conjugates, that's when I have the same first number, the same second number, but the first is being added and the second is being subtracted. Then all I have to do is take the first numbers and square them, minus the second number squared, and that will be my answer. It's that simple. So let me show you how we can use this to solve and simplify certain types of problems and actually make them easier. So here I have 87 times 93. So since these are two different numbers, what I'm going to do is I'm going to rewrite these as conjugates. Now remember, in order for them to be conjugates, they have to have the same first numbers and they have to have the same last numbers. So for example, 87 and 90 are both close to 90. So I'm going to make both the first numbers 90. Now 87 is 90 minus 3. 93 is 90 plus 3. So remember, in order for this to work, I have to figure out how I can make both the first numbers the same and the last numbers the same, but just the signs different. So since 87 is 90 minus 3, 93 is 90 plus 3. Now remember, when I have conjugates, my basic formula is a squared minus b squared. So this is simply going to be 90 times 90, my first number in each squared. So that's going to be 8,100. And then it's going to be minus 3 times 3, which is 9. And when I subtract that, I get 81 100 minus 9, that gives me 8,091. So that made it much easier to multiply those by simply writing them as conjugates. But remember, for them to be conjugates, the first number has to be the same, and the last number has to be the same, and one has to be subtracting and one has to be adding. Over here, I have the same number, so I'm not going to do conjugates. What I'm going to do is either addition or subtraction squared. So I'm going to do 70 plus 2 and 70 plus 2. So this is the sum. So since this is the sum of two numbers, remember I'm going to be doing a squared plus 2ab plus b squared. So remember, a is the first number, so 70 times 70 is 4,900. So I do the first number squared. Then I do 2 times the first times the second. So I'm going to do 70 times 2 times 2, and that's going to give me 280. So I'm going to add that. And then finally, 2 plus 2 is going to be 4. When I add all those together, I get 5,184. And those are my answers.